This does not commute, or does it? What I'm looking at is two different forms of a contravariant transformation of a tensor. Contravariant transformation form 1 just involves multiplication of three 2 by 2 matrices. Contravariant form 2 involves a 2 by 1, then a 2 by 2 by 2 by 2 times a 1 by 2. I guess I should call this a 1 by 2 and this a 2 by 1. I'm going to start by doing transformation form 1. This is a little bit maybe easier to start, but harder at the finish. This one goes, the r theta variables are going downwards, so it is del r, del theta, del r, del theta, and then the x, y variables are going to the right, so it's del x, del y, del x, del y. Then we'll have the a sub x, y going down, so it's a sub x, a sub y. And then the b sub x, y going to the right, b sub x, b sub y. And then this will be just kind of like the transpose of this one over here. It'll be del r, del theta going to the right, del r, del theta, del r, del theta, and then the dx, del x, del y going down, del x, del y, del x, del y. And the nice thing about this one, it's a familiar matrix operation to solve this. The bad thing is it gets really ugly. I'm going to go ahead and do this part first, and then this part, and then multiply the two together at the end. This will be del r, del x, a sub x, plus del r, del y, a sub y on the top of the matrix, and then it'll be del theta, del x, a sub x, del theta, del y, a sub y on the bottom. And then the second one will be a, 1 by 2 going del r, del x, b sub x, del r, no, b, let me write it. I never want to commute anything accidentally. So I was about to write del r, del x, bx, but I don't want to write that. If I do commute anything, I want it to be an event in this video. I don't want to commute anything by accident. B sub x del r del x plus b sub y del r del y, and then as our second term, b sub x del theta del x plus b sub y del theta del y. And then we will multiply those two matrices together. This is an outer product, so it's going to be a 2 by 2 matrix in the final version. And I'm just going to use the FOIL method consistently here, first, outer, inner, last, so we'll have a pattern. The first one is del r, del x, a sub x, b sub x, del r, del x. The outer is del r, del x, a sub x times b sub y, del r, del y. The inner is del r, del y, a sub y, plus, or times b sub x, del r, del x. And the last is del r, del y, a sub y, times b sub y, del r, del y. Then our, let's see, 2, 1 position, we'll have first del theta del x times a sub x times b sub x del r del x. Then the outer terms will be del theta del x, a sub x times b sub y del r del y. And our inner terms will be del theta del y, a sub y times b sub x del r del x. And for our last, we'll have del theta del y, a sub y times b sub y del r del y. Halfway finished. I recopied that, and we're going to do the other side here. For first, we have del r del x a sub x b sub x del whoops. Let's try that again. For first, we got del r del x a sub x times b sub x del theta del x. For outer, on the top, we have del r del x a sub x times b sub y del theta del y. For the inner on the top, we have del r del y a sub y times b sub x del theta del x. And for last, we have del r del y a sub y times b sub y del theta del y. On the bottom, we've got del theta del x a sub x b sub x del theta del x for first. For outer, we've got del theta del x a sub x b sub y del theta del y. For inner, we've got del theta del y a sub y times b sub x del theta del x. And for last, we've got del theta del y a sub y b sub y del theta del y. So if we zoom it out and let's put our little parentheses on this side, let's put it in the right color. It looks pretty ugly, and none of this, well, I guess some of these del theta, like you might put together del theta del x times del theta del x to get del theta over del x squared. But other than that, there's no simplification that you can do. Also, I'm not 100% sure that if these are displacement vectors, you know, del theta del x could be different before we apply a sub x and b sub x. Del theta del x could be a slightly different number after we move in the x direction or in the a sub x direction or b sub x direction. Although if a sub x and b sub x are definitely just force vectors or something that is not a displacement, then they wouldn't be different. So I called this one form 1, although I've got it listed second in this tiny box. I kind of thought this was a preferable form, but let's look at form 2, which kind of orders things different, and it puts these things on the inside and these things on the outside. All right, the way I'm going to write form 2 is a sub x, a sub y, in parentheses like this, and then this is going to be a strange shape. R theta is going to go del r, del r, del theta, while xy is going to go del x, del y, del x, del y. And then this one is kind of similar. It's going to be a shape kind of like this, and it's going to go del r, del r, del theta as the end changes, and then del x, del y as the x changes, del x, del y, del x, del y. And then our b is going to change. I'll write it as b sub x, b sub y in a double parentheses. Now I think I have a couple of different options for doing this one. I'm going to take I think I could take a sub x times del r del x plus a sub y del r del y, and then a sub x del theta del x, a sub y del theta del y to give a, what would that make it? It would make it a 2 by 1, and then do the same thing here, del r del x times b sub x plus del r times d sub y here, and then del theta del x times b sub x times del theta del y b sub y right there, and then we'd have this would give us a a 2 by 2. And so it would probably give, except for commutativity, except the terms, if there were any commutativity and problems with the multiplication, then that would be a problem. But otherwise, I think that would give us the same answer as before. What I want to do is show this thing fully expanded out first. We'll have our a sub x and a sub y matrix. And then this thing is going to form a 2 by 2 by 2 by 2 matrix, which is kind of interesting. It'll be del r del x del r del x. I'll just write that as del r del. I wrote this way too small. That'll be del r del x quantity squared, and then del r del x del r del y will be del r squared del x del y. We'll have del r del y del r del x. Then we'll have del r del y del r del x being here, del r del y del r del x, and then del r del y del r del y, which is del r del y squared. Then for the next part, we'll have del r del x del theta del x right here. Right here, we'll have del r del x del theta del y. Right here, we'll have del r del y del theta del x. And right here, we'll have del r del y del theta del y. And then right here, we'll have del theta del x del r del x. Actually, let's just look for an overall pattern here for a second. Make sure that I'm right in red. Okay, del theta del x del theta del y appears right here, right here, right here, and right here. Del r del x del r del y appears right here, and right here, and, well, this one's kind of messed up, but wait, no, not right there. Let's make it in a different color. Appears right here, del r del x del r del y del r del x del r del y. Del theta del x del theta del y appears right here and right here. It also appears here, 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 and here. So now I'm going to draw in my other parentheses and put in my b sub x, b sub y. Alright, I think I'm going to left multiply by the a sub x, a sub y first, so that everything will be very flat when I do that. And so I'll be able to fit it on the screen. So I'll have a sub x del r del x del r del x plus a sub y del r del y del r del x. And it'll be a comma. I don't usually write the commas, but because there's shorter space, I'll use a comma instead of a wider space. Times a sub x del r del x del r del y plus a sub y del r del y del r del y. So that is the first grouping, and then we'll do the same with this matrix over here. We'll have a sub x del r del x del theta del x, a sub x del r del x del theta del x, plus a sub y del r del y del theta del x. And then we ran out of room, but it's a sub x times del r del x del theta del y plus a sub y times del r del y del theta del y. All right, then I'll do a sub x times del theta del, nope, not that one, times del theta del y del r del x. Yes, that one. A sub x times del theta del x del r del x gives that, plus a sub y times del theta del y del r del x gives that. Then a sub x times del theta del x del r del y plus a sub y times del theta del y del r del y gives that. Then a sub x times del theta del x del theta del x gives that, plus a sub y times del theta del y del theta del x gives that. And finally, a sub x times del theta del x del theta del y gives that, plus a sub y times del theta del y del theta del y gives that. Now, multiplying all of that by b sub x, b sub y is going to be pretty easy by comparison, because it's going to be this term times b sub x plus this term times b sub y. So in fact, I'm going to just make it easy on myself by putting a b sub x in here, b sub x here, plus this times b sub x plus times that times b sub x. And so that turned that 2 by 1 into a 1 by 1. This will be, oh, this should have been b sub y, sorry, b sub y. This is going to be times b sub x plus this is b sub y times b sub y, then b sub x plus this times b sub y plus this times b sub y, this times b sub x plus this times b sub x plus that times b sub y plus that times b sub y. And that's going to be our final 2 by 2 matrix. So let's compare it to the matrix that we had before. Here I've got them scaled to about the same size. And I'm going to match up terms. Here's an a sub x, b sub x term in this one. Here's an a sub x, b sub x term in here. There's a del r del x, del r del x. So that one's good. Here's an a sub y, b sub x. Here's an a sub y, b sub x. There's a del r del y, del r del x, del r del y, del r del x. So that one's good. Here's an a sub x, b sub y term. And here's an a sub x, b sub y term. There's a del r del x, del r del y, del r del x, del r del y. That one's good. And here's an a sub x, b sub y term. And a sub x, b sub y. A sub x, b sub y. I've got an a sub y, b sub y here. I think I made a mistake. A sub x, a sub y, a sub x. This should be an a sub y here. So it was a mistake much earlier in the video. So maybe I'll correct that in the annotations. Then this one matches up. Del r del x, del r del x, a sub x, a sub x, b sub x, b sub x, del theta del x, del theta del x. This one matches up with this one. A sub x, b sub y gives you a sub x, b sub y. Del r del x, del theta del y, del r del x, del theta del y. This one gives you a sub y, b sub x, matches with a sub y, b sub x. Del r del y, del theta del x, del r del y, del theta del x. This one matches up ay, by with ay, by. Del r del y, del theta del y, del r del y, del theta del y. A sub x b sub x time is a sub x b sub x del theta del x del r del x del theta del x del r del x. A sub x b sub y, a sub x b sub y, del theta del x del r del y, del theta del x del r del y. A sub y b sub x, a sub y b sub x, del theta del y del r del x, del theta del y del r del x. A sub y b sub y, a sub y b sub y, del theta del y del r del y, del theta del y del r del y. A sub x b sub x, a sub x b sub x, del theta del x del theta del x, del theta del x del theta del x. A sub x b sub y, a sub x b sub y, del theta del x del theta del y, del theta del x del theta del y. A sub y b sub x, a sub y b sub x, del theta del y del theta del x del theta del y del theta del x. A sub y b sub y, a sub y b sub y, del theta del y del theta del y, del theta del y del theta del y. Yes. Okay, so these are the same matrix. So I have confirmed that this form 1 that I've created, which is just a 2 by 2 times, you can multiply these together to get a 2 by 2 outer product, and this is another 2 by 2. So you can get a 2 by 2 times a 2 by 2 times a 2 by 2, and get the same answer as you get from taking this by this 2 by 2 by 2 by 2 matrix times this these two one-dimensional tensors, and these this 2 by 2 by 2 by 2 four-dimensional tensor. I'm going to try to play an excerpt from Dr. Physics A's video at 4112. Oops. Of course.
That's not quite the right way to do it, but essentially you've got two sum terms here, which I'm just going to simplify here, multiplied by dym by dxr, and then you've got a dyn dxs times axr bxs. That's that term and that term. But what is this? Well, if you look at this term up here, you'll see that it's just another tensor. In this case, it's the tensor in the x frame of reference, but its indices are r and s. And that I'm going to call equation 4. And I'll put a block round that because we may need that in the future. And that is called, it gets a technical term, it's called the contravariant transformation. It's the transformation from the y frame of reference to the x frame of reference for tensors. There is an equivalent.
Okay, so what the implications are here is that you can pull this out, and nothing is bracketing anything. You can have that 2 by 2 by 2 by 2 matrix over here, and that and multiply it by the outer product of these two vectors. So you got a 2 by 2 by 2 by 2 times a 2 by 2, and get the answer that I've got with the contravariant transformation form 1 and contravariant transformation form 2. So what I need to do is, I think it might take me a little bit of time, but I want to see if I can confirm that there is a confirm or reject the possibility that you can actually separate that out and put it on the right, and actually multiply that out and multiply those the 2 by 2 by 2 by 2 by the 2 by 2 and see if we can get that. I'm going to save that for another video though, because this one has got longer than I thought it would, as usual. Thank you for watching.